So if I start with the definition of the gamma function, which is gamma nu is equal to 0 to infinity e to the power minus t to the power nu minus 1 dt, nu greater than 0, right? If I put, let's say, I have to calculate gamma half, right? So what I'm going to do, I'm going to adopt a little bit of technique here, that we put t equal to u square, some u square in the integration, and I say dt is equal to 2u du, and the limits does not change because t equal to 0, t equal to infinity, mean u is equal to 0, u infinity, and u to the power minus u square, and u square u to the power 2 nu minus 2, and dt is 2u du. So when you see, you get 0 to infinity e to the power minus u square e to the power 2 nu, oh sorry, u to the power twice here, u to the power 2 nu minus 1. So thus you get as gamma nu. Okay. Similarly, I can change the variable and I can write down same gamma nu as 2 e to the power minus v square v to the power 2 nu minus 1 dv. After all, v is a dummy variable. In a sense, is an integer. It is the variable on which integration is being done. So its symbol actually does not matter, right? It will be integrated over after all, right? Now what I'm going to do, I'm going to multiply this 2 with 3. So I'm going to get gamma nu square in the left hand side, and in the right hand side I'm going to get 0 to infinity, twice of all these things, 2 twice 4, right? Which means e to the power minus u square plus v square, okay, and u to the power 2 nu minus 1, v to the power 2 nu minus 1, and du dv. So basically double integral with the same limit 0 to infinity. My aim is to calculate gamma half. So let me put nu equal to half in the 4, equation 4. So if I use this thing here, so that will be a lot more easier for me, because that left hand side will be giving me gamma half square. And when I put the nu equal to half, so let's see what I'm going to get here. E to the power minus u square plus v square, and u to the power nu minus 1, when nu is half, so 2 nu minus 1 is 2 into half minus 1, that is 0, right? So u to the power 0, v to the power 0, both will give me 1, and your integration will reduce to the rather simple form. Now you can convert it into the polar coordinate. That will be easy now. U is equal to r cos theta, v is equal to r sin theta. So du dv will be replaced by area element r d theta dr, and e to the power minus r square. Now r will go from 0 to infinity, of course, and theta will go 0 to pi by 2, right? Why? Because we are taking this entire thing 0 to infinity. You see, the x is, it is kind of a x now, it is kind of a y now. They are varying, the x is varying from 0 to infinity, y is varying from 0 to infinity. When it happens in first quadrant, x is 0 to infinity, y is also 0 to infinity. When it happens only in first quadrant. So you have restricted your integration in the first quadrant. If you have to think in terms of theta, theta is a complete circle 0 to 2 pi. In the first quadrant, you will go from 0 to pi by 2. That's why I have put the limit 0 to pi. Okay, so now you just integrate it. So now again you can put r square, let's say some z. So 2r dr is dz, and theta will get integrated over, of course, because there is nothing in the integrand depending on theta. That gives me pi by 2, and r goes from 0 to infinity, so as z goes from 0 to infinity, and e to the power minus z, and r is z to the power half, and dr is 1 over half r to the power minus 1 and dz. Okay, so which means it gives me pi 0 to infinity z to the power half. R is nothing but z to the power half, so r minus 1 is z to the power minus half. Okay, so ultimately what do you get by integration? You get pi 0 to infinity e to the power minus z dz. Now what's the integration of this? This is pi e to the power minus z upon minus 1, 0 to infinity, which is pi. When I put infinity, I get 0. When I put 0, I get 1. So pi. So okay, So gamma half square is equal to pi. That's my left hand side. So gamma half is, this gives me that gamma half is root